All right, let's jump right in. Today, we're unlocking an absolute superpower for IT support and software engineering. We are going to master Charles' web debugging proxy. Think of it as the ultimate man-in-the-middle tool for getting advanced network visibility. Seriously, if you've ever felt completely blind trying to debug an app that's just failing silently, well, this is the explainer for you.
Okay, let's dive into this. Here is our roadmap. First up, we'll look at why we're moving beyond standard browser dev tools. Then, we'll tackle the macOS SSL proxying setup, because that is honestly where most people get stuck. Third, we'll actively inspect some real API requests. Fourth, we'll simulate errors on the fly. And finally, we'll walk through a real-world scenario, debugging a completely mysterious payment failure.
So, let's start with Section 1, Beyond Browser Dev Tools, Seeing the Invisible.
If you work in IT support, you definitely know the absolute pain of a user swearing up and down that it's broken, only for you to open the standard browser console and stare at absolutely nothing. Not a single red error line, just silence, right? So why do those blind spots happen? Well, browser dev tools are great, but they're heavily restricted. They really only show you traffic from one specific browser tab. They give you almost zero visibility into mobile apps, backend microservices, or native desktop applications. Now contrast that with Charles Proxy. Charles acts as a system-wide local intermediary. By default, it listens on port 8888 and literally intercepts everything routing through your machine. External APIs, native iOS apps, Android emulators, background scripts. Charles catches the whole shebang. It sits right there, right between your apps and the internet.
But there is a catch. Let's move to Section 2, macOS SSL proxying setup, decrypting the traffic.
The modern web is encrypted with HTTPS, right? So by default, Charles just sees this traffic as an unreadable encrypted tunnel. To actually read the data flowing to endpoints like httpben.org or your company's internal API, we have to empower Charles to decrypt it by securely installing its root certificate. And here's exactly how we do that on macOS. To perform this secure man-in-the-middle decryption, Charles needs to act as its own certificate authority for your machine. Step 1. In Charles, click the Help menu, then Install Charles Root Certificate. Step 2. This action automatically opens your macOS Keychain Access utility. Step 3. Search for that Charles Proxy CA certificate you just added. And Step 4. Okay, this is the critical step where almost everyone fails. You absolutely must double-click that certificate, expand the Trust section, and manually set it to Always Trust. Without this explicit permission, your operating system's security layer is just going to reject the proxy, and your connections will simply fail.
And this brilliantly illustrates the payoff. Just look at the left side of this comparison. Before enabling SSL proxying, your intercepted HTTPS traffic is just garbled, unreadable binary data. You literally cannot debug that. But look at the right side. Once you trust that certificate in your keychain and enable SSL proxying for your target domain within Charles, wow, it decrypts the stream into a clean, beautifully formatted, fully readable JSON payload. The invisible suddenly becomes visible.
Now that we can actually read the traffic, let's jump to Section 3, Inspecting API Requests, Finding the Clues.
We have the data flowing in, but how do we actively read it to diagnose complex issues? When you intercept an API call, you need to know exactly what to look for so you aren't just staring at a wall of code. There are 4 absolutely critical components every support engineer should check. First up, the request headers. This is where you verify authorization tokens and cookies to ensure the user's session is actually valid. Second, the JSON payload body. What exact data is the front end trying to send to the server? Third, the HTTP response codes. Is the server returning a healthy 200 OK, a 400 bad request, or maybe a 500 internal error? And finally, query parameters. Checking these elements methodically, that is exactly how you solve the puzzle.
Now, what's really interesting is how Charles presents all this information to you. In its dark themed UI here, notice how we're zoomed in on a specific HTTP 200 OK request. Charles splits your view into structure, which cleverly organizes requests by domain into folders, and sequence, which shows them chronologically as they happen. And notice how it automatically syntax highlights the JSON response payload. You don't have to mentally parse a giant wall of text. Charles formats it perfectly so you can rapidly pinpoint the exact data you need for precise debugging. It's a real game changer.
So far, we've just been passively observing. Let's move to Section 4 and see how this builds into active manipulation, simulating errors using the rewrite tool.
Imagine you're testing a web application and you need to know exactly how the user interface reacts when the server crashes. Do you get a graceful error message, or does the whole app just freeze up? So you might be wondering, how do we test a 500 server error without actually taking down the real backend for everybody else?
Well, the answer to that is the rewrite tool. It's a feature that enables automated, rule-based modification of requests and responses as they pass through the proxy. Instead of manually pausing and editing every single request, which by the way you can do using Charles's breakpoints feature, the rewrite tool automatically transforms the traffic on the fly based on rule sets you define. It runs completely seamlessly in the background.
Let's look at the exact steps to rewrite a status code. Step 1. Go to Tools, then Rewrite. Step 2. Add a new rule and set the type to Response Status. Now, Step 3 is where you really need to pay attention to a specific technical detail. Charles uses regular expressions here, so for the match value, you type 200 space dot star to catch all successful 200 responses. Step 4, the replace value. You type 500 internal server error. Charles expects this specific format where you include the message portion of the status, not just the 3-digit number. Turn this tool on, and your app will suddenly think the server is crashing, allowing you to test your error handling safely and perfectly. No way you could do that so easily otherwise.
All right, let's bring all these techniques together into Section 5, Real Scenario Payment Failure, Real-World Debugging.
This is where mastering Charles Proxy really pays for itself in a high-stakes IT support environment. We have all seen a support ticket exactly like this. The user frantically types, "My checkout just spins," and then says payment failed, right? There is no specific error code on the screen. There's absolutely nothing obvious in the browser console, just a vague, maddening front-end failure. Where do you even begin troubleshooting this?
Well, you fire up Charles Proxy, ask the user to attempt the checkout again, and you'll watch the traffic matrix. Notice that red 400 bad requests API call that pops up? The front-end application basically swallowed the error and gave the user a generic message. But Charles Proxy caught the failing API conversation to the payment endpoint happening right there in the background. We now have our prime suspect.
Let's systematically break this down using the workflow we discussed earlier. First, we verify the 400 status code, which tells us the server thinks the client sent a bad, malformed request. Second, we check the request headers to ensure the user's authentication token isn't missing or expired. If the headers look good, we move to Step 3, inspecting the JSON body for malformed data. Basically, what exactly did the app send to the payment gateway, and what did the gateway say back?
So the crucial point is right here in the response payload. We zoom in on the decrypted JSON body returned from the server, and it reads clearly, "Error, invalid currency code, code 400. Boom, mystery solved instantly. The front-end app was sending the wrong currency string for this user's region, and the back-end rejected it. Without Charles Proxy, you might have spent hours digging through back-end logs or just guessing. With it, you found the exact root cause in seconds.
Which brings us to a final thought to leave you with. If you can clearly see, decrypt, and even rewrite every single hidden API conversation your applications are having, what invisible bugs will you solve today? Charles Proxy isn't just a networking tool. It's honestly like an X-ray machine for your software. Thank you for joining me on this explainer. Go get those certificates trusted, start intercepting, and we'll see you next time.